Episode 71, titled Metric Selection by Goal, Aligning Measures with Business Outcomes, the main lesson is to choose metrics that reflect what success means operationally, because the metric you optimize becomes the behavior you get.
The exam cares because metric choice is not a math trivia question. It is a decision design question, and many wrong answers come from choosing a metric that sounds sophisticated while failing to match the real goal.
In real systems, a model can improve a technical score while making the business outcome worse, simply because the score does not reflect the costs and constraints of operations. Good metric selection starts by asking what decision is being made, what errors cost, and what the organization will do differently based on the output. When you align metrics to outcomes, you prevent teams from celebrating vanity improvements, and you produce models that are actually useful. The goal is to create a straight line between business success and what the metric measures. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A disciplined approach separates business goals from technical metrics and then connects them explicitly, because goals are expressed in operational terms, while metrics are expressed in mathematical terms. A business goal might be to reduce fraud losses, retain customers, prevent incidents, or improve delivery reliability, and each of those goals implies costs for different types of error. Technical metrics like error magnitude, precision, recall, or ranking quality are tools that approximate those costs, but they are not the goals themselves. The exam expects you to make the connection, meaning you should be able to say which metric reflects which operational pain and why. If you cannot explain how a metric supports a decision, you are likely optimizing the wrong thing, even if the metric is commonly used. This connection also clarifies what a good model means, because it anchors performance to consequences rather than to abstract numbers. When you make this explicit, you show that you understand metrics as decision proxies, not as trophies. When the target is continuous and errors have cost, regression metrics are the natural choice, because they measure how far predictions are from true values. The key is that different error measures reflect different cost structures, so you choose based on what kind of error hurts more.
If large errors are disproportionately expensive, you prefer a metric that penalizes large deviations more strongly, because operationally you cannot tolerate big misses.
If typical error matters most, and you want robustness to occasional extremes, you prefer a metric that reflects median-like behavior and does not let a few outliers dominate the score. The exam often tests this by describing an outcome like demand, time to complete, or cost, and then asking what metric fits, and the correct answer matches the metric to the cost of errors. A regression metric is also only meaningful when you have a stable, continuous target, which is why data quality and target definition still matter. When you choose regression metrics, you are choosing a direct measure of numeric accuracy tied to cost. When decisions depend on labels and thresholds, classification metrics are appropriate because the model's output ultimately triggers discrete actions like approve, block, investigate, or escalate. In classification settings, the same probability score can lead to different actions depending on threshold, so metric choice must reflect how the decision boundary will be set and what errors matter most. Accuracy alone is often misleading in imbalanced problems, because a model can be accurate by predicting the majority class, while failing to catch the cases that matter. The exam expects you to choose metrics that reflect the confusion matrix trade-offs, such as how many positives you catch and how many false alarms you create. Classification metrics are also linked to operational capacity, because a model that flags too many cases can overload teams and cause harm even if it catches many true positives. When you choose classification metrics, you are choosing to evaluate decision quality, not just prediction quality. Precision becomes the priority when false alarms waste resources or harm customers, because a false positive triggers unnecessary action.
In fraud and security operations, low precision can create alert fatigue, where teams ignore alerts because most are false, and that undermines the entire detection program.
In customer-facing contexts, a false positive can also create friction, such as blocking a legitimate transaction or forcing extra verification, which can harm customer trust and revenue. The exam cares because it often describes a constrained investigative team or a high cost of false positives, and the correct reasoning is to emphasize precision so that the actions you take are worth taking. High precision supports efficient use of limited resources because most cases flagged are truly relevant, which makes follow-up workflows sustainable.
Choosing precision does not mean ignoring misses. It means acknowledging that the system must be usable and that wasted interventions carry real cost.
When you prioritize precision, you are aligning the metric with operational burden and customer impact. Recall becomes the priority when misses are dangerous or expensive, because a false negative means you fail to act when you should. In safety and security contexts, missing a true incident can lead to harm that far exceeds the cost of investigating extra cases, making recall the more appropriate objective. In medical or compliance contexts, misses can create legal and ethical consequences, and the metric should reflect that risk. The exam often signals this through language about severe consequences or high stakes, and the correct reasoning is to emphasize recall so you capture as many true cases as possible. High recall can increase false positives, so it must be paired with capacity planning and guardrails, but the priority is to avoid catastrophic misses. In practice, many systems choose a high recall stage to screen broadly and then use additional steps to refine, but the metric focus still starts with the cost of missing. When you prioritize recall, you are choosing risk reduction over efficiency. Ranking metrics are appropriate when ordering matters more than hard labels, because many real workflows act on a top K list rather than a binary decision. In fraud and security triage, teams often investigate the highest risk cases they have capacity for, so the primary objective is that true positives appear near the top of the list. In churn prevention, teams may focus outreach on customers most likely to leave, making ranking quality more important than a perfect probability estimate at every level. The exam expects you to recognize that ranking tasks can be evaluated without committing to a single threshold, which is helpful when thresholds will change based on resources or business conditions. Ranking metrics reflect whether the model places the right cases ahead of others, which directly matches how prioritization decisions are made. A model can have modest classification accuracy, but still be valuable if it ranks effectively and directs attention to the right cases first. When you choose ranking metrics, you are aligning evaluation to triage and prioritization workflows. Calibration matters when probabilities drive downstream policy decisions, because a probability is only useful as a policy input if it corresponds to real-world frequency. If a model says a case has a 70% risk, stakeholders assume that roughly 7 out of 10 similar cases are truly positive, and if that is not true, policies based on the score will misfire. Poor calibration can cause systems to overreact, underreact, or misallocate resources, even if ranking is strong, because thresholds and risk tiers depend on the numeric meaning of the score. The exam often tests this by describing probability-based decisions like pricing, risk tier assignment, or resource allocation, and the correct reasoning is to consider calibration alongside discrimination. Calibration is also critical for communicating uncertainty honestly, because well-calibrated probabilities support transparent decision-making. When you include calibration, you are treating the score as a quantitative signal with meaning, not just as an ordering device. Mapping goals to metrics is a practical drill, and fraud, churn, and forecasting provide clear contrasts that the exam often uses.
For fraud, the goal might be to reduce loss while staying within investigative capacity and minimizing customer friction, which often points to precision and ranking metrics, with recall emphasized when misses are catastrophic. For churn, the goal might be to retain customers cost-effectively, which often points to ranking metrics for outreach prioritization and calibration if probabilities drive incentive spending and treatment intensity.
For forecasting, the goal might be to predict demand to avoid stockouts and overstock, which points to regression metrics aligned to error costs and to time-aware evaluation, because the future is the true test.
The exam expects you to connect each goal to the decision that follows, such as investigations, outreach, or inventory planning, and then choose the metric that evaluates that decision quality. These mappings are not purely technical. They are operational translations of what the organization values. When you practice these mappings, you become faster at choosing metrics that match the scenario's true objective.
Optimizing one metric can create unacceptable side effects elsewhere because metrics are partial views of system performance, and focusing on one can hide harm.
For example, pushing recall very high can flood operations with false positives, overwhelming capacity, and causing critical alerts to be missed amid noise. Pushing precision very high can miss too many true cases, leaving risk unmanaged and creating a false sense of safety. Optimizing a regression error metric might improve average performance while making tail errors worse, harming service levels for the worst cases. The exam tests this by presenting a strong improvement in one metric and asking what risk remains, and the correct reasoning acknowledges that a single metric cannot capture all consequences. This is why multi-metric evaluation is standard in serious systems. You choose a primary metric aligned to the main goal, but you also monitor secondary impacts. When you avoid single metric tunnel vision, you build models that improve the system, not just the spreadsheet. Guardrail metrics formalize this protection by defining additional measures that must not degrade beyond acceptable limits when you optimize the primary metric. A guardrail might track false positive volume, customer complaint rate, latency, fairness across segments, or operational load, depending on the system. The purpose is to prevent a model from achieving a high score in one dimension by causing unacceptable harm in another, which is especially important when the primary metric does not reflect all costs. The exam expects you to recognize guardrails as part of responsible deployment because they enforce that model improvements translate into system improvements. Guardrails also help iterate safely because they provide early warning when a change improves the headline metric but breaks something important. In practice, guardrails create a multi-objective decision, and shipping decisions often require acceptable performance across all guardrails rather than peak performance on the primary metric alone. When you incorporate guardrails, you are building a safety net around optimization. Communicating metric meaning is the final piece, because stakeholders must interpret results correctly for metrics to guide decisions rather than confuse them. You should explain what a metric measures, what it does not measure, and what trade-offs it implies, especially for metrics like precision and recall that depend on thresholds and class prevalence. You should also explain how the metric relates to operational action, such as how many cases will be flagged and what fraction are likely to be true, because those numbers translate directly into staffing and customer impact. The exam expects you to communicate without overclaiming, because metrics are summaries of performance under specific conditions, not guarantees of future outcomes. Clear communication also prevents metric gaming, where teams optimize a number without understanding the operational consequences. When you can explain metrics plainly, you enable the organization to make evidence-based choices and to adjust thresholds responsibly as conditions change. A helpful anchor memory is goal first, metric second, threshold third. Goal first means you start with what success looks like in the business process and what errors cost. Metric second means you choose a measurement that reflects that success and those costs, with guardrails to prevent harm.
Threshold third means you set decision boundaries after you understand score behavior and operational capacity, because thresholds convert scores into actions and should be tuned to constraints.
The exam rewards this sequence because it mirrors responsible model design. You do not pick a threshold before you know what you are optimizing, and you do not pick a metric before you know what success means. This anchor also helps you avoid a common error, which is selecting a popular metric without connecting it to the decision.
When you use the anchor, you build a coherent chain from business objective to evaluation to operational policy.
To conclude episode 71, choose one goal and then defend your metric choice, because defense shows you can connect math to outcomes. Suppose the goal is to reduce fraud losses while keeping investigation workload manageable and minimizing customer friction from unnecessary holds. A defensible primary metric is precision at a chosen review capacity because it measures how many flagged cases are truly fraudulent and directly controls wasted investigations and customer harm. You would also track recall as a guardrail to ensure you are not missing too many true fraud cases, and you would track calibration if the fraud score determines different intervention levels, such as light friction versus account lock. This metric choice is aligned because it evaluates the quality of the cases you act on, which is the real operational constraint, and it supports adjusting thresholds based on staffing without changing the core objective. That is the exam-ready reasoning. Choose the metric that measures success in the workflow you actually run, then use guardrails to prevent harmful trade-offs. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.